Alright, today we're doing graphing quadratic transformations. The first graph we have up top here is going to be your we've done the linear quadratic, or linear parent function. Now this is the quadratic parent function. The quadratic parent function always goes through the point 0, 0, which is its vertex, over 1, up 1, so 1, 1, and over 2, up 4, which gives us our other point. So 0, 0, 1, 1, 2, 4. It's just a pattern that it follows every single time. So even if it's shifted around, it will always follow the 0, 0 would be your vertex, over 1, up 1 would be your next point, and 2, 4 would be your third point, I guess. Alright, let's check out the different types of transformations. Alright, parent function. So we all know that our parent function has a vertex at 0, 0. Right? Our new graph also has a vertex at 0, 0. Okay? And then you just kind of go through all the steps. Shift. Did it shift up? Did it shift down? Did it shift left? Did it shift right? No, it did not. It stayed exactly the same. Alright, next. We got to figure out which of those lines is our parent function. So remember those points we just wrote up above? 0, 0, over 1, up 1, over 2, up 4. So our new graph is inside of our parent function, which means it is steeper. Alright? And it is not a reflection, or you'll see what a reflection is here in a second, but it is still going in the same direction, so no reflection. So this transformation right here would just simply be steeper. Alright, question number 2. Alright, same thing here. We got to determine which one of those is our parent function. So we're going to go over 1, up 1, over 2, up 4. So the inside one this time is our parent function. Our parent function, our vertex in our parent function is going to be 0, 0. Our new vertex is also, as we can see, is 0, 0. It did not shift up, down, left, or right, so we're going to say none. As far as steepness goes, it has started to flatten out, and we're going to call that less steep. And then reflection, it's still going the same direction, so no reflection. So steeper, and then this is an example of less steep. Okay, next page. All right. Now you can see we're starting to shift around on this page. Shift up and shift down. So that's going to cause us to change our vertex. First thing we need to do is identify that parent function again. So we have 0, 0, 1, 1, 2, 4. So that is our parent function up there. And it's pretty easy to see that it's our parent function because we know our vertex of our parent function is 0, 0. Next, what is our new parent function? Well, our new parent function our new vertex is going to be right there, which is going to be 0, negative 2. Okay? And now we're going to look at the shift. So did we shift up, down, left, right? We shifted down, so we're going to say down. Alright, now it's kind of hard. If you look at it right away, you're going to say, oh, the new one is less steep because it's outside of that number. But let's just go ahead and see our pattern. So if we're starting at, this would be 0, 0. Over 1, up 1 is still on the line. Over 2, up 4 is still on our new line, which means it has the same steepness. So our steepness is going to say the same. In this case, we said none. And it's still going in the same direction, so we're going to say no reflection. So that would be a shift down. Alright, if you observe the next one, you're going to say, oh, that's easy. It's a shift. Shift up. So let's just go through the details of it. Parent function is still this one, 0, 0, 1, 1, 2, 4. The vertex of the parent function will be 0, 0. Our new vertex is a 1, 2, 3, 0, 3. When you observe it, you can tell that it shifted up. Next, it looks like it would be steeper But let's just check that pattern again. If this was our starting point, so 0, 0, over 1, up 1 is still on the line, over 2, up 4 is still on the line. So that is going to be the same, so none. And then as far as reflection, it's still going in the same direction, so no reflection. So in example number 4, we had a shift up. All right. Going down here, you can tell we're starting to shift left and right. So it starts to become easier on this page to determine which one's our parent function. So we have the 0, 0, 1, 1, 2, 4. That just solidifies that that's our parent function. So the vertex is 0, 0. Our new vertex is shifted over to right here. That's going to be -4, comma 0. This time we shifted obviously to our left. Right. From our new vertex, we go over 1, up 1, which is on the line. We go over 2, up 4, which is also on the line. So it has the same steepness, so we're going to say none. And then when it comes to reflection, it's still going in the same direction, so we're going to say no reflection. So this is obviously a shift left. Just like before, we have the 0, 0, 1, 1, 2, 4. Our vertex is at 0, 0. Our new vertex is shifted to the right this time, and it's going to be right here at position 5, 0. The steepness, so you got to check that. So 0, 0, over 1, up 1 is still on the line. Over 2, up 4 is also still on the line, so it still has the exact same steepness as our parent function. So we're going to say none. Still both opening upwards, so we're going to say no reflection, and that's going to be a shift right. All right, number 7. All right, here we go. Parent function 0, 0, 1, 1, 2, 4. Okay, the parent function vertex is 0, 0. Our new vertex, even though it's facing down, is still at 0, 0. Alright, did it shift anywhere? Shift up, shift down, shift left, shift right. No, these are still the same numbers, so we're going to say no shift. Now when it comes to steepness, this one was 1, or 0, 0, 1, 1, 2, 4. Now we're going to look at those same patterns, but we're going to kind of look at them upside down. So if this is 0, 0, if I go over 1 and down 1, am I still on the line? Yes. If I go over 2 and down 4, am I still on the line? Yes. So it still has the same steepness. It's just facing downward. And so now, if the first one's upward and the second one's downward, we're going to call that a reflection. And you're obviously just going to think about this right here as a mirror, and you reflect your graph over that mirror. Okay. Number 8. Here we go. Parent function 0, 0, 1, 1, 2, 4. Vertex at 0, 0. New vertex at over 4. Up 3. So we have 2 shifts happening on that one. We shifted over. So we're going to shift to the right. We will also shift up. Now, we have to determine if the steepness is the same. So there is our 0, 0 vertex. We go over 1, up 1. We're still on the line. We go over 2, up 4. Also still on the line. So our steepness is not changing, it's staying the same. Both of our graphs are opening upward, so there is no reflection. So as far as a transformation, we had a left and right, oh sorry, whoa, man, it is early, isn't it? A right and up shift. Right, and last one. All right. So parent function 0, 0, 1, 1, 2, 4. Parent function vertex is at 0, 0. All right. We can tell that our new vertex is going to be down here, which is going to be 0, negative 4. That is obviously a shift down. Now when it comes to steepness, this is what we're looking for. 0, 0, over 1, up 1, over 2, up 4. Now you can see that your new line is clearly inside of your old line. Like if I was to attach these points, it's inside of that one. So it's going to be steeper. They're still going in the same direction, so no reflection. So our transformation here would be shift down, and then it's going to be a steeper. And that is graphing quadratic transformations.